Welcome to Chap Models. This lesson is part of Module 05, Chat Model Fine-Tuning. Let's get started. Let's now look at Lesson 5.1, Understanding Chat Models. Here we can see the chat model types. Let's now look at Overview. Here we can see the instruction formats. Chat models are more than just language models. They're specifically designed for interactive conversations. Understanding how they work, how they're trained, and how they differ from base models is essential for successful fine-tuning. Duration, 45 minutes. Difficulty, intermediate. Let's now look at learning objectives. Here we can see the system prompt design. By the end of this lesson, you will understand how chat models differ from base models, learn about instruction tuning and RLHF, master chat templates and formatting, understand system prompts, user messages, and assistant responses, know how multi-turn conversations are handled, understand context windows and memory. Let's now look at base model versus chat model. Here we can see the chat versus base model. Let's now look at base language model. Here we can see the chat fine-tuning pipeline. What it does: predicts next tokens. Training, large text corpus, books, web, code. Behavior, completes text, no instruction following. Example. Here's the bash code for this section, starting with input, the capital of France is. Let's now look at chat instruct model. Here we can see the SFT versus instruct. What it does: follows instructions, has conversations. Training, base model, plus instruction tuning, plus, optionally, RLHF behavior. Responds to user requests, follows instructions. Example. Here's the bash code for this section, starting with input. What is the capital of France? Let's now look at key differences. Here we can see the response format consistency. Aspect, base model, chat model. Training, text prediction, plus instruction tuning. Input format, raw text, chat template. Output style, continuation. Helpful response, instruction following, poor, excellent. Conversation, no context, multi-turn aware. Use case, text completion, assistance, chatbots. Let's now look at how chat models are created. Let's now look at Stage 1, Pre-Training, Base Model. Here's the bash code for this section, starting with large text corpus, trillions of tokens. Result, great at language, poor at following instructions. Let's now look at Stage 2, Instruction Tuning, SFT. Here's the bash code for this section, starting with Base Model. Here's the JSON code for this section, starting with 0. Result, follows instructions, helpful responses. Let's now look at Stage 3, RLHF, Optional, Advanced. Here's the bash code for this section, starting with Instruct Model. What it improves: response quality, safety and alignment, refusal of harmful requests, helpfulness and politeness. RLHF requires significant resources. Most fine-tuning uses SFT only. Let's now look at chat format anatomy. Let's now look at the messages structure. Here's the JSON code for this section, starting with say. Let's now look at 3 roles. Let's now look at 1. System, optional. Purpose, set model behavior, personality, constraints. When used, beginning of conversation, once. Examples. Here's the bash code for this section, starting with, you are a helpful coding assistant. Impact, steers model behavior throughout conversation. Let's now look at 2. User. Purpose, user's input, question, chocked request. When used, every user turn examples. Here's the bash code for this section, starting with, what is Python? Let's now look at 3. Assistant. Purpose, model's response. When used, every model turn, what you're training the model to generate. Examples. Here's the bash code for this section, starting with, Python is a programming language. Let's now look at single turn versus multi-turn. Let's now look at single turn conversation. Here's the JSON code for this section, starting with. Let's now look at multi-turn conversation. Here's the JSON code for this section, starting with JSON. Multiple back and forth exchanges, model maintains context. Let's now look at chat templates. Let's now look at what are chat templates. Chat templates convert the JSON messages format into the specific text format each model expects. Different models use different formats. Let's now look at example, Llama 3.1 chat template. Here's the JSON code for this section, starting with. Here's the bash code for this section, starting with begin of text, start header, ID is system, end header, ID. Special tokens, begin of text 1, start of conversation, start class header, ID, system, end header, ID. System message marker, EOT ID. End of turn, start to header, ID. User, end header, ID. User message marker, start to header, ID. Assistant, end header, ID cease. Assistant message marker. Let's now look at example, ChatML format, GPT-like. Here's the bash code for this section, starting with start system. Let's now look at applying chat templates in code. Load model apply, Llama 3.1 chat template. Now Tokenizer knows how to format conversations apply template and tokenize. Here's the bash code for this section, starting with begin of text, start header ID system, end header IDs. Note the empty assistant turn at the end. Model will generate response here. Let's now look at context, window, and memory. Let's now look at what is a context window? The maximum number of tokens the model can process at once. Llama 3.2 3B, 8,192 tokens, default. Extended can be increased to 128K with rope scaling. Let's now look at how context works. Here's the bash code for this section, starting with system prompt plus message 1 plus response 1 plus message 2 plus almost fit within context window. Example, simplified. Here's the bash code for this section, starting with system, 50 tokens. Let's now look at when context is full. Options. 1. Truncate, remove oldest messages. Summarize, compress history. Sliding window, keep most recent turns. 4. Error, reject if too long. Let's now look at managing long conversations. Always keep system message, keep most recent messages, use it. Let's now look at system prompt engineering. Let's now look at power of system prompts. System prompts guide model behavior throughout the conversation. Let's now look at examples. Let's now look at generic assistant. Here's the bash code for this section, starting with you are a helpful AI assistant. Let's now look at specific role. Here's the bash code for this section, starting with you are an expert Python programmer. Provide clear, working. Let's now look at personality. Here's the bash code for this section, starting with you are a friendly and enthusiastic science teacher who love. Let's now look at constraints. Here's the bash code for this section, starting with you are a customer support agent. Be polite and professional. Let's now look at output format. Here's the bash code for this section, starting with you are a data extraction assistant. Always output your ANS. Let's now look at system prompt best practices. Do. Be specific about role. Define output format clearly. Set tone, chart personality. Include constraints. Keep it concise, 200 tokens. Don't make it too long, wastes context. Be vague. Be helpful. Contradict training data. Over-constrain, model will struggle. Let's now look at testing chat format. Let's now look at complete test script. Load model test conversation format with chat template, generate, decode, extract assistance response. Let's now look at chat model evaluation. Let's now look at what makes a good chat response. 1. Relevant, answers the question. 2. Coherent, makes sense. 3. Consistent, matches personality, tone. 4. Contextual, acknowledges conversation history. 5. Helpful, actually useful to user. 6. Safe, no harmful content. Let's now look at manual evaluation checklist. Here's the bash code for this section, starting with chat response quality checklist. Let's now look at key concept summary. Let's now look at chat model, base model plus training. Here's the bash code for this section, starting with base model, predicts text. Let's now look at 3 key components. 1. Messages format, system, user, assistant roles. 2. Chat templates, convert messages to model-specific format. 3. Context, window, token limit for conversation. Let's now look at system prompts are powerful. Here's the bash code for this section, starting with system prompt unpersonality, plus behavior, plus constraints. Let's now look at lesson checklist. Here's the bash code for this section, starting with understanding checklist. Let's now look at key takeaways. 1. Chat models are instruction-tuned base models. 2. Messages format, system, user, assistant. 3. Chat templates convert messages to model-specific format. 4. Context window limits, conversation length. 5. System prompts are your steering wheel. 6. Multi-turn dash sing, entire conversation history as context. Let's now look at what's next. Now that you understand chat models, let's create training data. Continue to Lesson 5.2, Preparing Chat Datasets. Let's now look at additional resources. Llama 3.1 chat template, chat ML format, instruction tuning paper, RLHF explanation. Ready to create chat datasets. Let's go. That wraps up chat models. Well done on completing this lesson. See you in the next one.